Hey everyone, my name is Steven. I work at RISC Zero as the head of strategy. Today I kind of wanted to talk about the future of scaling, and more specifically, thanks to innovations in the ZK space, what does the multi-chain future look like? Just to kind of go over how we've thought about scaling in the past, right? How have we scaled Ethereum? Ethereum is naturally limited because it's a distributed blockchain, and it's limited in performance and functionality because of consensus. And to combat these two things, we've built rollups like Optimism, Arbitrum, ZK Sync. Those have given us a bit more TPS and a bit lower gas fees. And then on the functionality side, Ethereum runs EVM, which is naturally quite restrictive. And we've seen like Solana come out with SVM, MoveVM, Arbitrum Stylus. At RISC Zero, we've built RISC-V VM, a bunch of different ways for developers to interface with blockchains. But naturally, this is kind of how we've thought about scaling over the past 5 years. But given advancements in ZK, what does the ZK future look like? So an idea I kind of wanted to think about is this idea of a ZK coprocessor. I think we constantly hear this term thrown around, but like what actually is a ZK coprocessor? To figure that out, we can go on Google and search up what a coprocessor is. A coprocessor is a microprocessor designed to supplement the capabilities of a primary processor. That doesn't actually tell us much, but we can do some inferencing here. In this case, the primary processor is Ethereum, or we often refer to this as the base layer. And then how have we been scaling Ethereum? Well, we've been scaling Ethereum using rollups. So subsequently, there's an argument that can be made that all rollups are coprocessors, as they are supplementing the performance and functionality of Ethereum, which is the primary processor. Because of that, I kind of want us to think about like a ZK coprocessor as a generalized framework. It's a generalization of existing scaling methods like ZK rollups, as well as like ZK plasmas and validiums, which Vitalik has been pushing. But because of this, there's also some more novel models and architectures that we can adopt thanks to ZK. So now the question is, like, what else is a ZK coprocessor? Instead of building blockchains on top of blockchains, which is traditionally how we've thought about layer 2s and layer 3s, we can pursue an even more modular approach to scaling by breaking away even more components, such as DA, consensus, state, and more. And this provides us with a really flexible and dynamic solution space for scaling blockchains. And we'll go into a bit more of what this looks like in practice. So on the left here, this is how we've thought about layer 2s, right? The layer 2 itself has state, it has blocks, it has a centralized sequencer, and it has execution. And then Ethereum handles settlement, DA, and consensus. This is like the original modular thesis. What we've seen over the past 2 years is with the advent of Celestia, DA has been split off. And with really recent innovations in like BitVM and the Bitcoin space, people are starting to build native ZK Bitcoin bridges. So we can basically move settlements, we can move data availability away from Ethereum, producing a bit more modularity. What I'd like to propose today is an idea that completely abstracts away the major parts of a coprocessor towards Ethereum. In this case, both the state, that is the blocks and the account balances, as well as the sequencing, all live on Ethereum. And the only thing you're left with on the coprocessor is execution. What this looks like in practice, for example, is a DeFi app such as an order book can keep all of your account balances on Ethereum, and whenever it needs to do a swap or an exchange, it can send any sort of compute it needs to do and the states to the coprocessor, which can execute that and then submit the result back to Ethereum for settlement. What this practically means is any sort of DeFi app can take advantage of layer 1 liquidity without any sort of bridging, but also utilize ZK scaling to reduce their gas costs. And we're actually working with a few like order books in this case to use this architecture, as order books traditionally can't run on Ethereum because of gas. And the interface for their users remains MetaMask Ethereum mainnet, which is really critical for liquidity. So all this is powered by ZK. and it's uniquely enabled by ZK because ZK is this like universal language that bridges DA, consensus, and state between chains. Basically, what we've been able to do is really increase the modularity even further across the stack. Now sequencing and state remain their own little boxes. Theoretically, in the future, there could be unique custom options to slot in for every single one of these modular components. At RISC Zero, we're very committed to this idea, and we're actively working with quite a few partners to build this out. There are two main components that we've done to enable this new architecture. Our ZK VM enables any sort of developers to build ZK programs in 100% native Rust. This generally has made ZK significantly more accessible, functional, and performant. Instead of needing to hire a math PhD and 3 cryptographers, you can build your ZK circuits in Rust with ordinary developers. Additionally, for this new coprocessor design specifically, we've built a Foundry template that makes development extremely, extremely simple. What this practically means is you can basically build a coprocessor with just 3 files. With your existing Ethereum application smart contract, with your Rust-based ZK VM logic, this is where you offload any sort of scaling, any sort of compute, and then a serialization file that connects things up. So effectively, you can build this sort of roll-up but not roll-up ZK coprocessor with 3 files. And in practice, we're working with quite a few partners. More along like the traditional ZK roll-up lines, we've been closely working with AltLayer and Optimism. In these designs, the state remains on the rollup itself. The rollup executes EVM transactions and builds blocks with a centralized sequencer, and they're submitted back to Ethereum. This is how people have built ZK rollups in the past, and people are still using our architecture to build it today. This next generation of modular blockchains is quite exciting too. We're working with teams like Cetrea, who's building the first ZK rollup on Bitcoin, Layer N, which is building a unique DeFi-focused Layer 2, and then Eclipse, which is porting SVM onto Ethereum. All of these rollups take advantage of this new modularity in the stack. They're able to swap things out like the execution layer by adding in new VMs. They also move around states as well as DA. And finally, they can move around settlement. So they can, in Cetrea's case, settle to Bitcoin and take advantage of Bitcoin liquidity. So all of these new modular designs give us more functionality as they give us higher throughput and new VMs. And they give us more performance as well. So the future here and kind of how we're thinking about it is like innovations in the ZK space, specifically multi-chain verification, as well as improved ZK performance, basically will enable us to really expand like the solution space for coprocessors. That is moving settlements away from Ethereum and towards places like Bitcoin, Solana, Optimism, any sort of Cosmos app chain. Execution-wise, we basically support any sort of VM that can compile down to Rust. And for state, once again, we can move the idea of state and the idea of blocks and account balances across a wide variety of blockchains. I think the future that we kind of imagine here is a universal ZK layer, one that connects and translates consensus, state, DA across a whole variety of blockchains. Obviously, we're focusing on the largest ones today. But in the future, we also imagine things like connecting it to Web 2, bringing in off-chain identity, healthcare records, defense tech, AI. We're actively working with quite a few teams there, as well as like bridging and using this just as the ZK standard across a wide variety of use cases. So yeah, in conclusion, like there's quite a lot of exciting and revolutionary coprocessors launching over the coming months. We're quite excited about innovations in the space and all the new architectures and solutions that are being developed. Kind of how I think about things personally is 5 years ago, we were building alternate L1s and large monolithic blockchains. 3 years ago, we were building modular blockchains with the advent of DA. Now it's kind of the idea of modular scaling, completely abstracting away ideas such as like blockchains and really custom building solutions to your use cases. Yeah, that's all.
Thank you, Steven.